Welcome to Femap version 11.4. In this video we'll be looking at some of the new charting enhancements. In Femap's charting capability, the charting user interface has been updated. Specifically, the chart data series dialog has been streamlined to show only the most relevant information. You can use the Type drop-down to specify the type of data series to define, and this will determine the options that you'll see on the Data tab. The Style tab, however, remains consistent for all data series types. With this update, clutter is reduced and chart definition options are easier to find and set up. Femap allows you to perform real-time output processing, and we'll see how you can use the charting capability to process data on the fly, eliminating the need for any manual data processing. In this test model, we have von Mises elemental stresses in the results, and we'll convert those data to nodal output for the line of nodes along the top edge of the model and plot the results in a chart. So let's activate the charting pane and create a new data series. In the Chart Data Series dialog, we'll select the x-axis values in the global coordinate system and pick up the von Mises elemental stress vector, set processing to average, and select the top edge nodes group for output display. The resulting chart shows nodal data along those top edge nodes converted from the elemental results, showing how easy it is to convert output data on the fly in Femap. Similarly, Femap can perform data transformations on the fly, and we'll see an example of this using the same test model. This time we'll transform plate X membrane forces from a line of elements along the bottom of the model to the global coordinate system and plot them on a chart. As before, we'll activate the charting capability and create a new data series. So selecting the x-axis values, picking up the plate X membrane force output vector, this time we'll set a transform and elect to transform to the global coordinate system and pick up on the element group along the bottom edge of the model. The resulting chart shows X membrane element forces converted to the global coordinate system. Now, just for comparison, we can also go back and create another data series and select similar input, but this time without any transform, and we'll see the element data in its original form with the output relative to the element coordinate system, which is dependent upon the order of element connectivity with the nodes. Double complex data plots are available in Femap, so a secondary plot of phase angle can be shown alongside a plot of magnitude. Femap automatically retrieves complex data based on the selected vectors. To see how to set up a double plot, we'll use a simple test model that has already run a modal frequency response analysis. So let's activate charting and define a new data series of type vector versus set, opting for the output set value for the x-axis values. We'll just use the single output set for the modal frequency response analysis that's already completed, and the T3 translation of the three output nodes which are located on the right edge of the model. Femap then generates the magnitude plot of the selected output. Selecting chart options will allow us to set up a double plot with phase at the top and magnitude at the bottom. Femap can expand magnitude phase data according to a user-defined interval via the complex expansion data series type. Let's see how to set this up using the same frequency response analysis test model. We activate charting and select a new data series. This time we'll select type 3, expand complex. For the data, we'll select the first case and the T3 translation. The output target is node 51. And will specify a 10-degree phase angle increment for the plot. The resulting chart shows an expanded plot for the selected vector at all phase intervals. This makes it much easier to identify the max-min peaks for the selected output. To find out more, visit us at siemens.com/plm/femap or call your local channel partner.